Okay, so we have the question: use the binomial theorem to expand 1 plus x to the power of 7. So, what is the binomial theorem? Okay, binomial theorem. The binomial theorem is the summation of series. Okay, let me write it. Okay, let's say we have a plus b bracket to the power of n. Okay, so what is actually a plus b when we expand it? Okay, when we expand this thing, we actually have the summation. The summation from r equals to 0 until n. Okay, a to the power of n minus r times b to the power of r. Okay, so it is valid for n is the positive integer. Okay, when we have n is a positive integer, we will use this binomial theorem. This is we call it as the binomial theorem. Okay, I think you remember this binomial as binomial probability when you are form 5. Okay, so when we use the binomial theorem, it's actually give you a meaning that the summation from n r equals to 0, it means n 0 a to the power of n minus 0 times b to the power of 0 plus n 1 to the power of a to the power of n minus 1 times b to the power of 1 plus n c2 a to the power of n minus 2 times b to the power of 2 plus n c3 times a to the power of n minus 3 times b to the power of 3 plus dot 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 until you get n c n times a to the power of n minus n times b to the power of n. Okay, so it's actually n is the positive integer for this theorem. Okay, all right, so our question is expand this thing. Okay, this expression. Okay, 1 plus x to the power of 7. Okay, we will answer this question. 1 plus x to the power of 7. Okay, so just list down the value of n. N equals to 7, and a equals to 1, b equals to x. Okay, so we will use this binomial expansion theorem. Okay, so it's actually 7c0 times 1 to the power of 7 minus 0 times x to the power of 0 plus 7c1 times 1 to the power of 7 minus 1 times x to the power of 1 plus 7c2 times 1 to the power of 7 minus 2 times x to the power of 2 plus, okay, 7c3. Look at the pattern 0 1 2 3. Yeah, 0 1 2 3. This is 1 to the power of 7 minus 3 times x to the power of 3 plus 7c4 times 1 to the power of 7 minus 4 times x to the power of 4 plus 7c5 times 1 to the power of 7 minus 5 times x to the power of 5. Alright, and we continue. Plus 7c6 times 1 to the power of 7 minus 6 times x to the power of 6 plus 7c7. Okay, where you have n, and this is the same thing here at the head, and I don't think this is called it head, and also same as this thing. So we need to stop here. Okay, a to the power 7 minus 7 times x to the power of 7. Full stop. Okay, so 7c0 times 1 to the power of 7 minus 0. It's actually 1 plus 7c. 1 times 1 give you 7x plus 7c2 21x squared plus 7c3 35x cubed plus 7c4 35x to the power of 4. 7c5 21x to the power of 5 plus 7c6 7x to the power of 6 plus 7c7 1x x to the power of 7. Just leave x to the power of 7. So we have the expansion for 1 plus x to the power of 7 is actually 1 plus 7x plus 31x squared plus 35x cubed plus 35x to the power of 4 plus 21x to the power of 5 plus 7x x to the power of 6 plus x to the power of 7. It's actually the expansion for this. Okay, so first of all, just leave the value of n, a, and b from by using this theorem. Okay, you should remember this theorem. I don't know whether the theorem is given or not, but you should remember that. If the theorem is given, you should know how to use it. Just not okay. So that's all for our lesson today. The binomial theorem explain this basic thing when the power is integer. Okay, so that's all.